Hello and welcome to another episode of PEEPanEIP, an educational video series where we discuss an Ethereum improvement proposal, upcoming upgrades, and the basics of Ethereum blockchain. I'm Pooja Ranjan from the Ethereum Cat Herders, and today we are going to discuss EIP-3855 PUSH0 instruction with the co-authors Alex Beregszaszi, Hugo de la Cruz, and Paweł Bylica. A quick intro to the proposal. EIP-3855 is a standard track core EIP, which was initially proposed in February 2021 and currently is in CFI, Consider for Inclusion, for Ethereum Shanghai upgrade. For people who don't know CFI, it simply means there is a rough consensus by the client developers to implement the proposal and prepare it to be deployed with the following network upgrade. We'll learn about what changes are brought by EIP-3855 in a while. First, let me welcome our guests today. Thank you for joining us, Alex, Hugo, and Paweł. May we begin with a quick introduction before we get to the proposal? Anyone can go first.
Okay, I gotta go first then. Yeah, my name is Alex, and I've been working on Ethereum for several years now, both on the Solidity language as well as with this team on various improvements to the protocol itself. Initially, the team has been called EIP, but last year we have rebranded to Epsilon because the work we have been doing has been way beyond what EIP was about. And for the past 2 years, we have done, actually not two, at this point it's like 2.5. We have done a lot of research on the execution layer, and more specifically on EVM improvements. But we not only create proposals from our end, but we also do review other proposals made for the EVM. Hugo, you want to go next?
Hi everyone, my name is Hugo de la Cruz. I'm part of the Withdrawn team. I joined on December 2017 when the EIP team started, and currently mainly working on the Withdrawn team, basically for some this kind of analysis regarding the proposal from the team, and also from any other proposals.
Hi, my name is Paweł. I started working on EVM very early, back in 2014, and since then the journey mostly follows what Alex explained. So I was working on EVM in early days. Then we had a period of WebAssembly excitement, and we are back to EVM right now. So yeah, my work is mostly maintaining C++ implementation of EVM and proposing and reviewing other proposals for improvements.
Well, thank you so much for introduction. I know people are looking forward to learning this proposal, so let's just peep in.
Okay, let me share my screen. Okay, hello everyone, my name is Hugo de la Cruz. Today I'm going to talk about EIP-3855, the PUSH0 instructions, which is currently on review status and considered for inclusion in the Shanghai network upgrade. So the value 0 is a very frequently used value, especially by instructions expecting offset as input. Here we have some examples of opcode dealing with offset. We have, for example, call data copy, code copy, etc. We have many opcodes dealing with offset, and another common usage is when calling call opcode. The contract might prefer setting the return data parameters to 0, and later make use of return data size and return data copy to receive the results of the previous call. So this EIP-3855 introduces a new opcode, PUSH0, with a cost of 2 gas. It is introduced as instruction number 5F, which is contiguous to the existing push instructions. One of the motivations of this EIP is to reduce the gas usage and the contract size. For example, currently, if we use the PUSH1 instruction to push the value 0, we need 2 bytes, costing 400 gas at deploy time and 3 gas at runtime. If we use this PUSH0 instruction, it would only require 1 byte, costing 200 gas at deploy time and 2 gas when executing the instruction. Another important motivation for this EIP is to reduce the risk of contracts making use of other instructions in order to achieve this pushing the value 0 on the stack, maybe optimizing for gas. Here is a list of some instructions that contracts might use in order to achieve that. But the main risk here is that these instructions might change in the future in a way that it is not guaranteed that always is going to return the expected 0 value. One example of this is EIP-3733, which, if implemented, would have changed the behavior of return data size in a way that it is no longer ensured that this will return the 0 value at the beginning of the call. So if this change of any other change in the future change any of the opcodes that we see here, it will potentially break existing contracts making use of these instructions to get this optimization when pushing the value 0. And for this EIP, we also did some analysis on opcode usage, and especially for the push instructions. We traced transactions on 2 different nodes that were seeking a different block number. For example, one of the nodes was thinking at block 8 million when we were tracing, and the other node was thinking at block 12 million. And we got a histogram. We collected a histogram with all the opcode usage, including the push instruction, and we also have a special column for when we found PUSH1 pushing the 0 value, the specific value of 0. From this analysis, we found that PUSH1 and PUSH2 are the most common used opcodes from all of the opcodes. And among the specific push opcodes, we also have that PUSH1 and PUSH2 are the most common ones. And from push opcode usage, 11% of all the push opcodes, 11.39% of all the push opcodes are used to push the value 0 to the stack. Yeah, this is specific for the value 0, but we also did some analysis on other commonly used constants. For example, the 0, 1, 2, and 8, 31, and 32. We see that 0 is the most common one. We have 1, 2, and 32 as also very commonly used. In this case, for the commonly used constant, for example, for the constant 0, this is already solved by this EIP by adding the PUSH0 instruction. For the constant 1, it is commonly used in loops. This could be solved by adding the increment and decrement opcode, which Alex is going to talk about in the next slide. And for the value 2, it is commonly used by all contracts in order to emulate shifts, which is already solved by existing shift operators. And for values 31 and 32, it is more commonly used by the Solidity ABI. Now, Alex is going to talk about the increment and decrement instructions. Alex?
Yeah, maybe a slight clarification is that PUSH0, as explained by Hugo in the the first half of the slides, there is a certain number of motivation why PUSH0 is useful, because it definitely reduces the cases where other instructions are kind of misused in optimization cases. And given the design of the, you don't need to go back. Given the design of the EVM, these offsets are really common in every single contract. But on the Ethereum Magicians, if you want to scroll back to the final slide, on the Ethereum Magicians discussion thread, when PUSH0 was proposed, there was a question, how about other constants? And that's why we have conducted this analysis, looking at what others are common. And we have found that potentially the constant 1 could have a improvement because it's used in for loops for most of the time. And what happens in for loops is you need to increment the counter and then check whether you reached the desired end. But you could also go backwards. And if there would be some appetite for it, one could consider introducing 2 new instructions on top of like PUSH0 called inc and dec for increment and then decrement. This could provide also like a slight improvement, but I would say this is more on the side of only improving gas-wise, and it doesn't really have any of the other motivations we have for PUSH0. So as stated here, the benefit is just a gas reduction, but the downside is that maybe this would move the EVM too much in towards to a CISC instruction set, which is an instruction set which has a lot of instructions for minute details. And so far, Ethereum has and EVM has avoided this. Lastly, I wanted to mention a fun fact is even though contract bytecode once in the state can be deduplicated. So if you have, for example, proxy contracts which have the same code, and you have like 100,000 of them with the same code, likely it is stored as a singular code on the disk of the node. So if you have like a 10-byte proxy contract, that's going to only take really just it's not going to take 100,000 times 10 bytes. However, when you do actually deploy it, you have to pay for that cost every single time. So we did like another calculation and checked all the contracts, how many bytes are wasted on pushing the number 0 with the push1 instruction. And we found that at the time, this was a year ago, at the time there have been 340 megabytes wasted on this. which equates to 68 billion gas wasted on deploying these extra bytes. By wasted, I mean if there would have been PUSH0 by from the beginning, this gas wouldn't have spent on this. It's just a fun fact. I think that's it from our side. If there are any questions.
Thank you so much for sharing this presentation and the detailed analysis charts and charts for opcode usage. That was great. And I think I saw it for the first time. So it was quite fascinating, and knowing about how much gas it can probably save on contract is nice to know. I do have a couple of questions that we came up from the proposal discussion on FEM and the GitHub issues. So my first question is related to the mnemonic. It's not a technical question, but definitely would like to understand the thought process behind. So a Fellowship of Ethereum Magician user wrote, love the idea, but maybe we should use a different mnemonic like PUSH0 for immediate, and that way we will have a room to grow. So I'm wondering, what is the thought behind using PUSH0? And do you think there could be an advantage of using different mnemonics?
It's hard to say. Nobody has really proposed anything super useful, at least maybe in my opinion. But there are two reasons why we have gone with PUSH0. One, this has been partially inspired by many risk instruction sets. For example, MIPS, which do have like a basically a constant zero register. And the other reasoning is I'm not sure, Hugo, if you could go back to the table with the PUSH0, PUSH1, the instruction numbers. Yeah, so basically in the EVM implementations, there's a piece of code which for the implementation of the push instruction, and that's the reason we have chosen the instruction 5F, because you can implement it with the same template. And if you do that, then just using the same mnemonic also makes sense.
Sounds good. Yeah. All right. My next question is related to motivation. So my question to you is like, it's a general thought that we try to put as much as information which is relevant and needed for developers, client developers to consider the proposal. This proposal 3855 has a mention of 2733, which is now withdrawn. Do you think that under this special case, because now that has been withdrawn, we can probably get rid of this information? It may be redundant.
No, I think it's a good indication of, I mean, even though if like 2733 is not currently pursued, should there be any other proposal which would influence the semantics of existing opcodes, then this problem would come up again. And I think that's the reason to have it there.
All right. Yeah, I was just curious because generally this is not the case, and we usually find proposal either in stagnant status or somewhere in the draft review, but this we know that is not going to go any further. Nevertheless, I think I'm happy with the answer here. Okay, I think that is good. And I don't know, there was no mention of any active implementation in any of the project. Just wondering, like, is there any active implementation that you are aware of? Now that it is in CFI, most likely every client will try to implement, but as of now, do you have any information on that?
It is implemented in implemented and merged in EVM1 and Ethereum JS, and it is implemented in Go Ethereum, but it hasn't been merged yet.
All right, that sounds good. Okay, that's all we have got. A number of questions for this proposal, and it's time to wrap up. Any final thing that you would like to add for this proposal?
Not from my side.
No, from me.
Well, thank you. Thanks, Alex, Hugo, and Pavel for providing the overview of EIP-3855, which may be expected with the Shanghai upgrade. This proposal is up for review, so anyone listening to this recording, if you are having thoughts on this proposal, please join the discussion in the discussion tool link provided in the description box. Thanks to all our YouTube viewers for watching and sharing feedback and comments. Should you have any questions on this or any other talk, let us know in the comment and share it with us on ETH Cat Herders Discord. Subscribe to the ECH YouTube channel if you haven't done it already. See you next time with another Ethereum improvement proposal. Till then, have a good one, everyone.